Okay, let's dive right into this explainer. We are going to explore a deeply universal and honestly incredibly frustrating human experience. You know the one? You lie down, completely depleted from the day, expecting to finally rest. But instead, your exhausted brain suddenly treats 2 a.m. like an urgent life or death emergency. Your mind boots up like a supercomputer running a stress simulation. Well, today we aren't just looking at a few basic sleep tips. We are actually uncovering a hidden operating system that runs beneath your conscious experience. We're going to decode the invisible biological forces that shape the quality of your life every single day, and we'll reveal how making tiny, informed decisions can completely alter your health trajectory for decades to come. So, why does this happen? We've all experienced the sheer frustration of racing thoughts in the middle of the night, right? You're just staring at the ceiling, replaying a completely minor conversation from 3 years ago, or obsessing over tomorrow's overflowing inbox. But I really want you to understand something fundamental right now. This is not a personal failure. It's not a lack of willpower. It's actually a profound biological paradox hidden deep within your nervous system. To truly fix it, we have to stop treating it like some annoying psychological quirk and start understanding the intricate machinery of the brain. Because this midnight panic, it isn't just a random occurrence. It is a highly documented, recognizable clinical state. Clinically speaking, this state of a racing mind at night is known as nocturnal cognitive hyperarousal, and it is a genuinely fascinating breakdown in your biology. You see, the transition from wakefulness to sleep isn't just about closing your eyes. It requires a massive, highly coordinated shift in your central nervous system. Your body absolutely must move from a high-alert sympathetic state, which is your survival mode, to a restorative parasympathetic state. But in hyperarousal, this natural transition completely breaks down. A whole complex network of hormonal and cognitive pathways just stays lit up, treating the quiet silence of your bedroom as a vacuum that urgently needs to be filled with magnified, unresolved stress. To understand exactly why this happens, we have to look at your endocrine system. Under normal, healthy conditions, your primary stress hormone, cortisol, operates on a very strict daily rhythm. It's supposed to reach its absolute lowest point right around midnight, which is what allows your body to initiate deep, restorative cellular repair. But here is the major modern conflict. Chronic daily worries and environmental pressures impair this incredibly delicate feedback loop. When you carry stress continuously throughout the day, you actually trigger unexpected late-night cortisol surges. It is literally as if your body believes there's a predator hiding in the room, gently elevating your heart rate and putting your autonomic nervous system back on high alert, right when it should be powering down. And this creates a profound nocturnal imbalance occurring right inside your actual brain structure. As you lie there in the dark, the metabolic activity in your rational prefrontal cortex, the logical, adult part of your brain that solves problems, starts to decrease and dial down for sleep. But because of that lingering stress and cortisol, your highly reactive emotional center, the amygdala, remains intensely active. So, without the prefrontal cortex acting as the logical adult in the room, the emotional amygdala essentially takes over the steering wheel. It begins processing minor daytime tasks, like, say, a mildly awkward conversation at the grocery store, as an urgent mortal threat. That is exactly why a simple forgotten email feels like an absolute catastrophe at 2 a.m., but feels entirely manageable by 9 a.m. It's brain chemistry, not truth. Let's go one layer deeper into this. At the cellular level, these elevated nighttime cortisol levels cause a very specific breakdown in your brain's communication network. They directly interfere with GABA. Now, GABA is your brain's primary inhibitory neurotransmitter. You can really think of it as a natural brake pedal that's meant to quiet neuronal activity and calm down that overactive amygdala. But chronic stress impairs GABA receptor sensitivity. It literally cuts the brake lines. This neurotransmitter imbalance leaves your brain in this suspended, overexcited state where inhibitory signaling just fails, allowing your thoughts to loop endlessly without any resolution. Now, what's truly fascinating is how our evolutionary origins and our unique DNA actually come into play here. Your specific genetic code can literally predispose you to this overexcited state. Take the COMT gene, for instance, which regulates how fast you break down dopamine in the prefrontal cortex. If you happen to have a slow-clearing variant of this gene, your brain stays highly alert and analytical right at bedtime. Or look at FKBP5, a variant that impairs the body's ability to lower cortisol. These specific genetic variants alter exactly how you process serotonin, dopamine, and stress hormones, meaning some of us are literally hardwired for pre-sleep hyperarousal. But hold on, because here is the most important insight of this entire explainer, and honestly, it's a profound relief. Your biology is not your destiny. While your genetics and neurotransmitters might set the stage for insomnia and racing thoughts, We are not passive victims of our neurochemistry. Not at all. We possess highly specific, scientifically validated protocols to manually override this biological architecture. We can intentionally hack this hidden operating system to force our nervous system to shift from survival mode into recovery mode. To prove just how powerful this manual override can be, let's look at a pretty fascinating experiment. Researchers at Baylor University brought 57 young adults into a highly controlled sleep lab. They wanted to test if a simple behavioral intervention, specifically writing in a journal for just 5 minutes right before bed, could actually alter the participants' sleep physiology and reduce that cognitive arousal. But here's the catch. They didn't just have them write aimlessly. They wanted to test the precise content of their thoughts. So, the researchers cleverly divided the participants into 2 distinct groups to really isolate the mechanism of worry. Group 1 was instructed to write a highly detailed, future-oriented to-do list of tasks they needed to complete over the next few days. Group 2, serving as the control, was asked to write a retrospective list, basically reflecting on tasks they had already successfully finished that day. The goal was to see what worked better for the brain, offloading future anxieties or cultivating a sense of past accomplishment. Astonishingly, the results showed that the group who wrote specific to-do lists fell asleep a full 9 minutes faster. Now, in the rigorous world of sleep science, a 9-minute reduction in sleep latency from a mere 5-minute behavioral shift is absolutely massive. The researchers discovered that the level of detail is everything. A vague list, it doesn't work. But a highly specific, detailed list gives the brain enough concrete evidence to feel confident that the tasks are safely stored externally. By getting the thoughts out of that looping neural network and onto paper, you literally manually shut down the cognitive tension that's keeping the amygdala awake. But what if you're already in bed, the lights are out, and the thoughts are spinning? Enter another incredibly powerful cognitive override known as cognitive shuffling. This was developed by cognitive scientist Dr. Luc Baudouin. You see, when we naturally transition into sleep, our thoughts naturally become fragmented, nonlinear, and totally nonsensical. These are called microdreams. Cognitive shuffling is the act of intentionally engaging in random, disconnected imagining to deliberately mimic this pre-sleep state. By visualizing a sequence of completely unrelated objects, you gently steer your brain away from structured anxiety. You are essentially tricking your nervous system into believing it is already dreaming. Now, as powerful as those mental tricks are, sometimes the mind simply can't calm the mind. When that cognitive tension is just too high, we have to bypass the brain entirely and address the body directly, using somatic interventions. These are specific physiological techniques designed to calm physical hyperarousal. They manually force your autonomic nervous system out of that fight or flight sympathetic state and push it deep into the rest and digest parasympathetic recovery state. Let's look at one of the most immediate somatic overrides available to us, the physiological sigh. This was discovered back in the 1930s and has been recently popularized by neurobiologist Dr. Andrew Huberman. It's actually an involuntary reflex we naturally do during deep sleep, but you can trigger it voluntarily. Here's how it works. You take a deep inhale through the nose, immediately follow it with a second sharp inhale to reinflate any collapsed air sacs in your lungs, and then release a long, slow, sighing exhale. Studies out of Stanford show that just a few cycles of this rapidly increases vagal tone, offloads carbon dioxide, and dramatically lowers your heart rate in real time. It is quite literally a biological kill switch for acute stress. Similarly, we can look to the ancient yogic practice of pranayama, which inspired integrative medicine specialist Dr. Andrew Weil to develop the famous 4-7-8 breathing technique. He refers to it, very appropriately, as a natural tranquilizer for the nervous system. These deep, slow breathing techniques aren't just folklore or placebo. They have profound neurobiological effects. They actively trigger the relaxation response, originally documented by Harvard cardiologists, which lowers your blood pressure, reduces the sensation of pain, and perfectly preps your body for deep rest. The specific mechanics of 4-7-8 breathing are exactly what make it so effective. By specifically inhaling for 4 counts, intentionally holding the breath for 7 counts, and then extending the exhale for a full 8 counts, you are doing something remarkable. You are deliberately overriding the fast, shallow breathing pattern that characterizes the stress response. That extended exhale acts directly on your vagus nerve, releasing neurotransmitters like acetylcholine. And that forces your biology, regardless of what your anxious thoughts are doing, into a state of deep, undeniable physiological tranquility. And this brings us to the grand synthesis of everything we've explored in this explainer: health,
Deep sleep, emotional resilience, and stress recovery, they are not a collection of isolated daily habits. They form a deeply intertwined operating system. Think about it. Your pre-sleep thoughts influence your cortisol. Your cortisol influences your GABA. Your GABA influences your nervous system, which alters your breathing, which drives inflammation, and ultimately shapes your long-term cognitive aging. Revealing this interconnectedness shows us that regulating our biology at 2 a.m. isn't just about trying to sleep a little better. It's about protecting the entire trajectory of our long-term health.
As we wrap up this explainer, I want to leave you with one profound realization. Your biology is incredibly powerful, yes, but you hold the manual override. Every single night at 2 a.m., you are faced with a choice. Allow the hidden operating system to run unchecked in survival mode, or take the wheel. So how will you use these invisible biological forces to not only reclaim your rest tonight, but to actively reshape the trajectory of your cognitive longevity for decades to come?